We will start that how practically the peripheral base address and bus base address we find out from this reference manual, and how we'll define in our actual code implementation where it is defined, how to identify the addresses of these peripherals and buses. So today we'll discuss that defining the base addresses of HB1 peripherals and base addresses of these peripherals and APB1 and APB2. So if we go into the reference manual and if we go in the system and memory overview, then in the memory organization we can see that the this is the information that how the memory structure look like. So that is the APB1 bus, and these are the peripherals. That peripherals are this much of peripherals. This all peripherals are connected with the APB1 bus. So till the okay, let's see about there is also APB1 or not. Yeah, that is APB2. That means APB1 end here. So that is the end address of APB1 bus, and that is the starting address of APB1 bus. And this starting the so APB1 base address should be this. And if we add the offset 0, that means the APB1 base address is equal to the base address of timer 2, and the timer 2 end address is this. In this way, if we add the offset of this much from this APB1 base address, then you will get the timer 3. In this way, you will define the base address of every peripherals, and similarly the base address of APB2 is this one. This one is the APB2 base address, and this is also the base address of timer 1. Okay, so if we add the offset 0 in APB2 bus, then you will get the base address of this peripheral timer 1. And the end address of timer 1 is this one, but APB2 end address is APB2, that is the HB1. That means the APB2 end address is this one. So that is the end address of APB2, and that is also the end address of these peripherals. So if we add the offset of this much with the APB2 base address, then you will get the peripheral address of this one. So in this way, you have to define all the peripherals base address and APB base address. So let's see where it is mentioned in our code, actually how it is defined. So if we go your code and if you open the driver, and you will also open the ChemSys file, and in the ChemSys file if you expand the device, then in the device you will get the ST. You will expand that, and in the ST there is this folder present. If we expand that, then there is the include and source file. So if we expand the include file, then you will see that there is the 3 folder is present, and this folder basically the uh, carry the information of this microcontroller or device specific base address and all the peripheral structure, register structure. So we have discussed that there is the structure that is the structure of this uh, peripheral register. There you will see that lots of structure present and depend on the every peripherals. So these registers uh, are responsible to uh, enable, disable, and accessing the different peripheral. So that's a structure will used to uh, use any type of peripheral in your applications. So through this registers structure we can use the peripherals, and that is the base addresses of the peripherals, and flash, RAM, ROM, everything is mentioned here. The that is the addresses, all the peripherals, that is the bus addresses. These are the bus addresses. This is basically the memory informations, that which memory. Suppose that the flash base addresses is this one, and the if we say that RAM addresses is base addresses is this one, RAM 1 and RAM 2 plus and here. In this way you have to mention all the, so flash base address is this one, that is mentioned basically here. Okay, so then if we talk about the peripheral addresses, then this is the peripheral addresses. So the APB timer 2 is connected. We have seen that timer 2 is connected with APB 1, and if we add the offset 00, then that will be the timer 2 base addresses. In this way all the peripherals base addresses mentioned here, and we use to access this peripherals registers, whatever the registers we need to control the peripherals. To these base addresses we go into further every registers address, and we access the peripherals. So there is basically the ASB1 is connected, while the GPI is connected with ASB1. So if you see, you will see that the, all the GPI are basically connected with ASB1 high speed. So this is the ASB bus, and ASB bus starting address is this, and this is also the starting base address basically of GPIO also, and all the GPIO is connected with this bus. Okay, so that is actually basically here in that ASB1 connected with this all these peripherals, as well as the I2C, SPI, UART that is connected with the APB1. If you see the reference manual, you can easily understand that these peripherals are connected with APB to this much of peripherals connected with the APB2 bus. Then addresses of these peripherals registers. So now we have seen that the peripherals base addresses start from this address. If we go that peripherals start from this address, this is the peripheral base address. So all the peripherals start from this address, sorry, and then go above. So that is mentioned here, that the peripheral base address, and that if we the peripheral base address of APB1 base address, and we add some offset, then we'll get the APB2 base address, and if we add another some offset, then we'll get AHB1 or AHB1 base address. So now we will talk about basically the GPIO. So we know that GPIO is connected with the HB1 peripherals, and the HB1 peripheral starting address is this base address, basically this. And if we talk about the GPIO, yeah, we now we are going into differ, basically from this peripheral base address we come to the HB base address. Now from the HB base address we come to the GPIO base address, and GPIO base address is basically this, and this has some range of address, and in between this address what is present. So if you go deeper, then you will say that from this address if we add the offset 00, then you will get this address. Okay, and that is basically the address of register mode register. That is the address of mode register. If we add, so that is basically the 32-bit registers. So next, if we add this 4 bytes, then you will get the register of output type registers. Then if we add these offsets, then you will get the speed registers, another 4 bytes. So if we add this offset, you will get the pull up pull down registers. So how a GPIO you will use in your application, that's all the things you can control through these registers. So if you want to use any pin from this port GPIO as per your requirement, so to accessing this registers, this register, you can use your or you can fulfill your requirement by controlling these registers. That is basically that register is input data register, output data registers, and the BSS registers. Okay, so that is the deeper. If we go this reference manual, and you can understand that how the mode register actually uh, controlling the mode of a pin. So we'll do in our exercise also. Thank you. If you have any doubt, you can comment me.